Dear students, welcome back to the channel. So today we are going to discuss one of the important non-linear effects in optical fiber communication. The topic is self phase. The topic is self phase modulation, also called SPM. That is self phase modulation. So what is self phase modulation? In what condition it is occurring? First you need to understand that concepts. So basically it's a phenomenon that occur when high optical power is launched into the optical fiber. When high optical power is launched into an optical fiber. So we studied that. We know in optical fiber we will launch the laser with the power of in milliwatts, right? Now question is the self phase modulation that occur only when optical power is launched into the optical fiber. So that means when we will launch the high optical power. So the answer is, so when like a system like a WDM, that is wavelength division multiplexing, there you can see here many signals will be multiplexed together. So in such a condition, this non-linearity situation, it's play the major role. So it due to the Kerr effect. So what is the Kerr effect? So you need to understand that is the refractive index of the array of optical fiber becomes intensity dependent at high optical power. When optical power, its light travel through the optical fiber, when high optical light travel through the optical fiber, the refractive index of the fiber change with respect to the optical intensity. This is a Kerr effect. You can see here the change in the refractive index with respect to the optical power. So ideally you need to understand that in general condition the refractive index of the fiber should be constant, but at high power levels it become intensity dependent. That is called Kerr effect. Okay, so what is this effect will introduce? What is the main cause of this effect? That you need to understand. See, you can read now. If you read, see this description very clearly. The self-induced phase shift experienced by an optical field during its propagation in optical fiber. It's a self-induced phase change. Okay, that what happened when it induced phase change. So because of the refractive index change, the phase of the optical signal also change. Okay, this phase change is produced by the signal itself. It is called self phase modulation. It's a change in the phase. That is the phase modulation. That is self phase modulation. So very important point to remember is SPM changes the phase of the signal. It does not directly change the amplitude or power. That is very important. The self phase modulation will change the phase of the signal. It does not directly change the amplitude of the power. Okay, let me explain this graph very clearly. You will understanding the concept of self phase modulation. So the top graph, it's about intensity versus time. This is the intensity. So x-axis is time. So what it tells you? So you can see here, it's a blue curve, right? The blue curve represents the intensity of optical pulse. The intensity is maximum at the center of the pulse. You can see here the intensity is maximum at the center of the pulse, and the intensity is lower at the front and back. It's lower at front and back. Why? Due to the change in the phase. Let me go to this graph. In this graph you can see frequency versus time. So what happened? You see a change in the frequencies. See, at the front of the pulse the frequency decrease. You can see at the the frequency decrease. So at the center of the pulse you can see the frequency remain almost constant. See here. So it's almost constant, you have a high peak. At the back of the pulse, you can see the frequency increase. See, at the back of the pulse, frequency is here. You can see the frequency is increase. Frequency is constant here. You can see higher intensity. Here, it's lower, right? So this change in the frequency is called across the pulse. This you want to understand across the pulse. Across the pulse is called crimping. Okay, it's called crimping. Okay, so what happened generally? So this leads to the broadening. This leads to the pulse broadening and signal distortion. That is an important cause of the self phase modulation. Important cause of the self phase modulation. So let me explain you this image. You will understand very clearly. So see here, I am sending an input pulse. It's entering the fiber, right? Intensity across the time. So you can see it's a gentle smooth shape that is launched into the input optical pulse as pulse travel through the fiber. So consider you have a situation like n number of input has been launched into the fiber, that is a wavelength division multiplexing. So there is a chance of high power intensity that will alter the phase inside the fiber. It leads to the self phase modulation. So what actually happening? So due to the self phase modulation, as pulse travel through the fiber, the Kerr effects play the major role. The fiber refractive index, now it become the optical intensity dependent, right? The higher intensity generally it means for more phase shift. It's called self phase modulation. So after traveling through the fiber, the pulse exists with the distorted pulse. So you can see that what is the difference between this input pulse and distorted pulse. It leads to the, that is the main cause is self phase modulation. You can see the spectrum is become broadened. Okay, so this is a main one of the nonlinear effect that will exist in the optical fiber in the scenario of wavelength division multiplexing. I hope you understand. So we'll meet in the next lecture.